Today we're going to be looking at another divide and conquer algorithm, and this is trying to calculate the maximum subarray sum. Basically what that means is if you're given an array, you want to find the subarray where if you add all the values together, that'll be the maximum. And so I'm just highlighting here in my example array, this would be the maximum subarray because if you add all the values together, it will be 12. 5 plus 1 plus 6 is 12. And yeah, there's no other subarrays that is as large as that. So before I even get into how the divide and conquer algorithm approach works, I just also want to point out you could do a naive approach, which is to calculate every single subarray sum and then compare which is the largest. And that is actually going to be O of n squared time because you're going to do a double for loop. The divide and conquer algorithm is a little bit better. And because you're dividing up the work and then doing work on smaller chunks, that's going to be O of n log n time. But there's actually an algorithm that's even better, and it's known as Contiguous algorithm. I'll actually spell it out, but this one is actually O of n time, and so that's going to be the best bang for your buck. And if you just want to know what's the best way to solve that, I highly suggest looking up that algorithm. But this is still worthwhile to learn how to do the divide and conquer approach, especially if you just want practice doing divide and conquer problems, or just learning recursion in general. So the approach is to consider three main cases, right? So divide and conquer, you're always dividing. And so this algorithm, you're going to divide it in half. And the first case would be that your maximum subarray is in the left-hand side. And then the other case is it could be on the right-hand side. But the third case is that it could be straddled between the left and right side. And so the way you're going to solve this is you are first going to divide. So, okay, I've already divided, and I noted that in pink. And then you want to find the left max sum. And this is going to be done recursively. And for this array, on the left-hand side, that would be the first two elements. And then you are also recursively going to find the right max sum. Let's see, that would be the last element, 7. Yeah, that's larger than 6. And then what you're going to do is you're going to calculate the middle max sum. And I think the reason why I had such a hard time understanding how this algorithm worked was because I kept thinking, oh, well, you're calculating the right and left recursively. This is, in some way, it has to calculate the middle recursively. And that is not true. Calculating the middle max sum is not done recursively. And I'll just show how that works. So essentially, to find the middle max sum, you're starting from the middle, and if this is my midpoint, I just highlighted it in pink, then I'm going to first look at the left-hand side and say, okay, based on the middle point, what is the max left side? So what this means is I'll start here and I'll say, okay, so we have the value 6. Now if I keep moving away from the middle point, 6 minus 20, that's negative 14. And then if I move one more time, that is 12, negative 12, and then this is, what is this? Negative 3. So our maximum left-hand sub array, oh my gosh, is just going to be 6, starting from the middle point. And we're going to do the same exact thing on the right side. So starting from the middle, our max subarray is 1, and then plus 5 is 6, minus 11, that is negative 5, plus 7 is 2. Well, okay, this is our maximum starting from the middle. Let's highlight this, that cute green color. And then we just add the left and the right hand starting from the middle together, and that will give us our middle maximum sum. And notice I just calculated that not recursively. And then what I'm going to do is take all three values, so those are colored blue, green, and purple, and take the max, and that will tell you the maximum. And so in this case, the max is our middle spanning sum. So that was just the overall approach, but let's get into some pseudocode explaining how it works. So here's the pseudocode, and I've just copied the approach bullet points that I included in the first slide. So I'll just kind of give an overview of how this is working. Essentially, remember for any sort of divide and conquer problem, or literally anything that's recursive, you need to have some sort of base case. And for our case, it's going to be, if we have an array A, L is going to be the leftmost index, and R is going to be the rightmost index. So our base case is if the left equals the rightmost element, then we are just going to return that value. And this is just saying if our array is of size 1, there's one element, then we're going to return it. Otherwise, we're going to keep dividing in half, which I'm just using the same colors. Whoa, that's way too big. How big is this one? That's better. Just using the same colors from here to make it clearer, but we're going to keep dividing until we reach arrays of size 1. And we're recursively calling to find the left maximum size. So let me again switch colors and match that, and then we're also going to calculate recursively the right maximum. Okay, so the last portion is calculating the middle max sum, and that is actually the bulk of our code. And whoa, let me use a bigger. Yeah, so it's the bulk of our code, and that is, again, remember, calculating any values that could be spanning between the left side and the right side. So let's now look at an actual example array, and I took the array that we had in the previous slide again, but yeah, let's walk through this pseudocode about how it's working. So I'm going to keep dividing until I reach nodes of size 1. So I've already done this because, oh my gosh, it was a pain. So yeah, I keep dividing till I reach nodes of size 1. And then once that happens, I'm returning those values. And then for each one, I'm going to calculate the L max. So the left side max. So now if we're looking at our else condition, we're looking at the non-leaf nodes. So the L max would be 9 because that's what's going to be returned by our base case. And also just think about it an array of size 1, well, the left and the right max are going to be the same. But so let's zoom in. L max is going to equal 9. And then the right max is going to equal 2. Okay. And again, these values were simply calculated with recursion. Okay, so what's different is now we need to do the purple one. And so that's saying, if we're starting at C, which is the center value, so of this little array, I just made it bolder. I'm going to go from this, first going to go from the C value until I reach L. And this is kind of trivial for this small array, but remember, I'm moving from the middle outwards. So the left-hand sum is going to equal 9, and then I'm going to do the same. This portion of the code is now going from the center to the rightmost node, and I find like the maximum. This is just kind of the same I did previously, and so the right-hand sum starting from the center is going to be equal to 2, and then the maximum is adding the 2 together. So 9 plus 2 is 11, and so middle, I'm just going to say equals 11. Gosh, this is getting really tight, but that's okay. Okay. And now I'm going to return the max of the 3. And the max is, in this case, is the middle. So I'm going to say 11. Okay, so I'm not going to do this for every single array because that's going to take forever. But we can move one more up just for fun. So now we're looking at this array. Assume that these were already calculated. This max subarray of this one is 11, like the total value is 11. The max would just be 6 for this one. So if we're looking at this specific array, we're first going to find the center value that's calculated right here. Actually, it's not the center value, it's the center position, and then what we're going to do is we are going to calculate the L max, which is already determined here. So I'll color code that to be green. And the right max was also calculated recursively. I'll highlight that blue. Now what we have to do is calculate the max middle sum. And so again, we start from C, that bolded line, and then we're going to move from C down to L. And we're going to add the next array element if it increases the total sum. So we have 2, and then we add 9, and that's 11. So both of these should be included in our middle sum. And then now this portion is looking at going from the middle to the right. So that's why I set it equal to 0. It's because I don't want to add negative values, right? That's not increasing our sum. So this is bringing it to negative 20. But even if I move one more, that's negative 14, and that is not greater than 0. So we're actually not going to add anything from the right side to our middle sum, and so from the midpoint, our middle sum is 11. And then we're going to return the max of the left, right, and middle. And the middle and the right are the same value, 11, so we're going to return 11 because that's the greatest. And I'll do one more just for the heck of it. But honestly, wait, try to just pause and do it on your own, because hopefully you have the process down by now. But I will just go one more time. Okay, so our right-hand max is 7, left-hand max is 11, and then middle, we're going to move from the center and keep seeing if we go and add another element, is it increasing our total sum? So 6 minus 20 is negative 14, and then it'll be negative 12, and then negative 3. So that's still not greatest to the max, which is 6. So our left-hand max from the center is 6. And I'll highlight that on the array. Okay, now what we're going to do is do the second portion. We just did this part of the code. Now we're doing the second part, moving from the center to the right side. And that's, yeah, okay. Moving from the center to the right side, we're going to keep adding. So 1 plus 5, 6 minus 11. Oh my god, I can't do math. Negative 5 plus 7 is 2. So our max sum is 6, so it's these two. And then we're going to return the greatest max sum. And the middle array is going to be 12. So we're comparing 11, 12, and 7, the blue, green, and blue, green, and purple, goodness. And then we've determined that our max sum is 12. So now we know our max subarray are these values. And yeah, that's it.